This is going to be a short video going through the Unit 5 practice quest. This is the unit that is all about the periodic table and different parts of the periodic table, and then knowing the different trends that exist there. So first off here, I'll just go through these multiple choice questions, kind of remind you of some things that you should know. All right, so the first one, going through some vocabulary here, it says the rows of the periodic table are called periods, so that is A. Something to think about with this, know the rows are periods, that the columns, are, obviously you should know too, are called groups or families, but just generally speaking, yeah, make sure you know the different parts of the periodic table and what things are called. Number two, the following property means that a substance can be molded into shapes. Molded into shapes, that is malleability. Morphology is not a real thing as far as I know. Ductility is the ability to be drawn into wires. Conductivity is its ability to conduct heat or electricity. Which of the following substances is a nonmetal? So you need to know the general parts of the periodic table here, know where the metals are and where the nonmetals are. And you should see that D, fluorine, is a nonmetal. All right, which of the following is a member of the halogen group? The halogens are group 7A or 17, depending on the periodic table that you're looking at. They include fluorine, chlorine, bromine, and iodine. And so iodine here would be a halogen. Number four, which of the following groups is known for being unreactive and hard to detect? On this one, we're going to be talking about the noble gases. They don't react with anything, that's why they're called noble. And then also, they're so hard to detect that we didn't know that they existed for a really long time. That's just something that I mentioned in the course of teaching this. Which of the following is not a property of the halogen group? Mostly radioactive, that's the one that's not a property of the halogens. If you look through the rest of it, halogens do exist as diatomic elements, which are things like Cl2, Br2, I2, F2, so they exist as diatomic elements. So in nature, when you find chlorine, it's bonded to another chlorine atom, so two of them together, they're kind of coming in pairs. And they do combine with metals to form salts, like sodium chloride is a salt of sodium and chlorine, but potassium chloride is another one, calcium chloride, calcium iodide, those are all salts. All right, which of the following is not a property of the alkaline earth metals? It says they're less reactive than alkali metals. That's true. They have lower densities than the alkali metals. That's false. They actually have higher densities than the alkali metals. They're not found as free elements in nature. Is true. All right, which of the following has the smallest atomic radius? So looking here at the atomic radius, it gets small as you go up and to the right. And so helium is the one there that is the most up and to the right out of those, so it is C. Boron has this many valence electrons. For this, you're just looking across the columns of the periodic table. If you look across the columns, it goes 1, 2, and then you skip the transition metals, and then boron's group is 3, carbon's group is 4, nitrogen's group is 5, oxygen's group is 6, fluorine's group is 7, and then the noble gases are 8. All right, so boron, as I said, that group has 3, so D is the correct answer on this one. This one here, we are ordering these from smallest to largest. And so smallest to largest, we go starting here with, let's see, the smallest one would be up near the top, which would be nitrogen, and then aluminum. Oh, this is the electronegativity. Sorry, it's not atomic radius, it's electronegativity from smallest to largest. And so, actually going to go the other way. So we'll start at the bottom. We go, that would be rubidium, Rb. And then the next one would be titanium. And then iron, and then aluminum, and then nitrogen. Okay, this one, it says, what happens to the atomic radius as you travel down a column? So the atomic radius as you're traveling down a column is going to get larger. So that's the first step. The reason the atomic radius gets larger is because you're adding more energy levels onto the outside. So that's the explanation. So there are essentially only 6 questions that I'll probably ask you here. So I would ask you for the group trend or the period trend for one of the 3 different properties that we're talking about. So atomic radius, electronegativity, and ionization energy. And I'd ask you what happens as you go down a column, or what happens as you go across a row. What happens for any of those different things, and you'd have to explain why that trend exists. So make sure that you're familiar with the different rules for why the different trends exist, because I'll likely ask you a similar short answer question when we go through this.